This video deals with another chapter, if you will, that help you to solve statistics problems, really using Excel. This one covers normal distribution, and the video deals with the traits of normal distribution and using them to solve problems quickly in Excel on your device. And you need to recognize, or I hope you do, that normal distribution is one of the most used functions in Excel when you're trying to solve statistics problems or answer questions of statistics. Normal distribution is very prevalent in school, the business world, and for personal things that you might be working on at home. And if you're one of those gazillions of people that get up in the morning or go to sleep at night saying to themselves or to whoever will listen, I hate math, then you can get yourself out of that position by going through this video on a step-by-step basis. And while we're on this subject, you're going to find all of my videos on my website. And depending on what it is that you're trying to do, hopefully there's going to be a video that's going to answer your question. So you can copy the address down, it's fairly short, and go into the website anytime you want, and there'll be links to click on that'll take you to the various videos that I have posted. I would hope at the same time that you're going to remember to subscribe to my channel. When you do that, you automatically will be receiving copies of new videos as I post them, and I'm pretty much committed on a weekly basis to be posting new videos, so it can be very helpful to you. So really, I guess, without further ado, let's get you into the little one-room schoolhouse of Excel, where we can take a look at normal distribution. And so when we're in normal distribution, let's start out with what a particularly easy question or problem might be, and one that would be typical of what you would be able to solve using the normal distribution function. And so here is this typical problem. And you're going to see I'm going to repeat it in the next stuff that I show you several times so you don't lose sight of it. The average height of a flowering cherry tree in the nursery is 11 feet, so the average we're looking at is 11. And if the heights are normally distributed with a standard deviation of 1.6 feet, find the probability that a tree is 13 feet tall or less. And you should really think of what 13 feet tall or less means. We'll talk about that a little bit later in the video. Now, there is a manual formula that will allow you just to put in all the various variables and then using pencil and paper come up with the answer. Here's the formula. And at this point, many people, and myself I guess included, would be shuddering to say, holy moly, I'm really not going to do that. Even if I know what all those letters stand for, I got to be looking at 20 minutes plus to be able to get that all listed down and go through with the calculations that will give me the answer. So if you're like me, you would give that a major thumbs down. You're not really interested in doing anything like that whatsoever. What you want to do is you want to recognize, and here's the problem again, that instead of going through a long manual process with a few clicks into Excel on your device, you're going to be able to come up with the answer. Now, I've relisted the problem again so it stays up front on the top of your head. Recognize that normal distribution, if you graphed all the information that you were given, you would end up with a bell curve. And the bell curve would look something like this. The closer the data was to the average, the middle, the skinnier the bell would be. But even if the stuff is far apart, there's a wide variance in the data, it would still look like a bell curve, and it would be wider instead of flatter. You'll notice on the bottom the symbols -3 starting on the left-hand side there is showing you with the Greek letter O. That's the O with the little tail on it. And what those mean are standard deviations. You'll notice that the middle is 0. And so when we put in the standard deviations over there, you can see that half the bell, the standard deviation is 0 because it occurs at the average point of the data. And then you'll notice that the standard deviations go from -3 on the left-hand side to +3 on the right-hand side. Most stuff in statistics doesn't go beyond 3 standard deviations, plus or minus, because when you're at 3 standard deviations, you've covered yourself for about 99.7% of the answers to all of the problems. And so now I've highlighted that standard deviation for you at 1.6 feet because you're going to need to use it when we get into the formula. Now, so now we're in a position where we're going to actually go through and we're going to be coming up with the answer to this question without going through a long, involved manual formula. Because we know that for a normal distribution, the graph is a bell curve. And while there's no simple formula to calculate it, using the power of Excel, which is what we want to do, we'll be able to come up with this answer in not 20 minutes, not a half an hour of calculation and pulling our hair out, but using just a few simple clicks. So let's start out with what we have then. Well, we know that the X that's in our previous manual formula is 13 feet because the problem asks us to find the probability that the tree is 13 feet tall or less. We know that the average value, or the mean, is 11, and that's signified in the formula by the Greek U with the little tail on the left, and we'll put that in there. We know that the standard deviation is 1.6. Once again, we're given that. You need to be given that in order to work out a problem in normal distribution. And so we're going to substitute the various z values on our graph by just showing you where they would be, putting them on the graph. You know, -3 with the Greek letter O is going to be on -3 standard distributions, or 3 z's. That's what that really means. So now you got the 1.6 showing between the 0 and the +1. And we could actually put in 1.6 in every one of those boxes on that bottom level because every one of them are the same. Z-scores are always the same for every, -1z, -2z, and so on. The last thing we're going to need is showing true is for continuous, and that's going to need a slightly bit more explanation, which I'll give you shortly when we're working on the formula. So now we have pretty much all of the information that we need, and our answer is going to be the area under the bell from the X value, in this case 13, all the way to the left. All of the area underneath that bell. When we calculate what that area is, we're going to have the number that we're actually looking for. And so I'm showing you that it's going to start at the 13 there and go all the way over to the left-hand side. So once we do that, we're going to be able to quickly come up with the answer. Now, this explanation is taking a lot longer than it would be to just go in and solve the problem. But I'm trying to get you to understand what it is that we're doing. So now here is the problem written all over again. I don't want you to lose sight of what it is that we're trying to do. Here's the graph again. Shows the 13 on it. I'm putting, again, the various z values on the graph so you could see it. Standard deviation just showed up. That's that 1.6 standard deviation. The 13, again, is the value of x. The 11 is the mean. So now we have all of the information that we need to enter the formula. And what is the formula? Well, it's a function in Excel. And it starts out, and I'm going to be doing this for you on an Excel document in another few seconds. But you start out by keying in equal norm distribution. And when you do that, you'll notice that a line shows up on the bottom asking you for 4 pieces of information. And what are the 4 pieces of information that you're being asked? Well, it's x, which we know is 13. It's the mean, which we know is 11. It's the standard deviation, which we know is 1.6. And the last thing, it says cumulative. And what cumulative is asking you is, do you want the value or probability of just x occurring, or do you want the value of everything up to x? And what is everything up to x? Well, maybe there's a tree that's only 2 feet tall or 1 foot tall or whatever. By putting in the word true, we're telling Excel that we want the cumulative value of what we put in for x and all of the numbers leading up to x. Don't be confused. It's not a hard concept for you to be able to absorb. And so this is what you're looking at. When you put in all of those numbers, 13, 11, 1.6, and then true, and you'll notice each separate by a comma, you'll have everything that you need. And what will be generated by Excel, as you'll see in a second, is the answer that it is we're looking for. Okay, we're finally at the point now where we're going to actually do the work on an Excel spreadsheet. And what you're looking at, as promised, is an open Excel spreadsheet. And at the risk of being redundant, you can see that I have copied the problem over again one more time. And I've listed in 4 columns there, or 1 column D, the 4 variables that we're going to need to solve this problem. X, the first one, is the number that we're being asked about. And actually this time we're being asked to find the probability that a tree is 13 feet or less, which means 13, 12, 11, so on, all the way from 13 down to the smallest tree. And so for X, we're going to go ahead and we're going to enter 13. Then I'm going to go to the mean, and the mean is nothing more than the average, and it's a given number. The average is 11. We're going to enter that in that field. Then we're going to go down to standard deviation, and again, it's given. These are all things that we need to do in order to be able to solve it. Now, the next thing it's asking us, do we want a cumulative answer? Which in this case we do, because that's 13, 12, 11, everything from 13 feet down to the smallest tree in that nursery. So when our entries are put in, for cumulative, we want to tell Excel that we wanted to give us a cumulative answer, and so we're going to enter the word true. The options that we have for this field are only true or false. Either we want a cumulative number or we don't. And in this case, that's what we want. Now we're going to go through and we're going to actually enter the function. Remember, file away that ugly formula that we said we're not using that. We want to do this in a couple of clicks. So we're going to put in equal, and we're going to start typing normal distribution. A drop-down menu is going to open, and right now it's showing us everything that started with NO. If I put in the R, now it's showing us in everything that's NOR. And you'll notice in the functions that it's showing us. The first item is norm.dist, and that'll work actually. But I'm going to go down a little further in the list, and I'm going to use the one that just says norm distribution. You might say, why are there different ones? Well, without going into a lot of detail for you, is Excel's been around for a long time, and as Microsoft has added improvements and upgraded it, they have changed how you get at some of the functions. What you just need to take solace with is what I'm giving you is going to work on any version of Excel you have on your device, so you won't need to worry about it. So for X, which is highlighted there, I'm going to enter 13. For the mean, I'm going to enter the 11. For standard deviation, I'm going to enter 1.6. And for cumulative, I'm going to enter true. So in fact, I have all of my numbers there. I'm going to resist hitting the return key, and I'm going to hit the green check, and it's going to tell me that the probability is 0.89435. Now, let's stop here for a half a second and look at the second menu bar toward the top. One of the items, about 5 or so over from the right side, it says ABC 1, 2, 3. I'm going to select that, and the drop-down menu that's going to open, it's going to give me a lot of choices. The first one, it says I can increase the decimal places. Right now, I'm showing 5 decimal places. I don't know what you're showing when you do this, because I don't know how you used Excel the last time you opened it. So there isn't any way for me to tell that. But I do know that if the cell is highlighted with the answer and I tap increase decimal one time, it will do just that. And if you look at it, you'll see that I've done it. Well, maybe the request or what you want to do says you only want 4 places in the decimal. So I'm going to now tap decrease decimal. I'm back to 5 one more time, and now I'm showing it in 4. Maybe you want to show it as a percentage. That could be your option. I'm going to go down that more, and you'll see one of the options that I have is for a percentage. When I do that, Excel is going to show me the percentage in 2 decimal places. That's the default. And so there it is. I still have the ability, if I wanted to have 3 decimal places, to hit that ABC 1, 2, 3 and go ahead and increase my decimals. And so as you see, I'm now showing it to 3 decimal places. One other thing before we leave this. I took the time to write down on the sheet what my variables were. Some people, and I happen to be one of them, find it a little easier when they're doing their entry, if they've taken the time to do the variables, is to put in equal, type normal distribution, start typing it anyways, select normal distribution. Now it asks me for the same stuff, but instead of keying in 13, I'm going to highlight the 13. You can see I've got it highlighted. For the mean, I'm going to highlight the 11. You'll notice also it's really nice. It shows me what I've done, even in a different color, so I can see that I've done it right. For standard deviation, I'm going to hit the 1.6. That's another color. And then for cumulative, I'm going to select true, and that's a 4th color. Now I'm happy that I got all of the right things highlighted. I'm ready to enter, and I'm going to resist hitting the return key, and I'm going to again hit the green check, and you see I get the same answer. Just a few clicks, and keep in mind that horrific formula that we looked at and we didn't use. So let's move on now and look at something else in the way of normal distribution. So as we go on, I've started out here showing here's the original problem. We did 13 feet or less, that's the problem. You looked at the entry, it was pretty easy to do. We went ahead and did it a couple of different variations of that. And so the question I have is, what if the problem was different than that? Because here we have almost the same thing written again, but this time it's find the probability that a tree is 13 feet tall or more. And when we look at the graph, it's the same graph that we had for 13 feet or less, right? When we did the first part of that, the 13 feet or less, we wanted to calculate the area from this black line that represents the 13 feet all the way to the left on the graph. And we came up with our 89% and whatever. This graph also is used for the second problem that I've given you here. It graph looks the same, but how are you going to enter the information in Excel? That's really what the question is. And I raise it this way, hopefully so it'll stick in your head. It's easy to fall into a trap. And for lack of a more substantive way of saying it is, there's a banana peel out there that you could slip on if you're not careful. The question is, are you going to recognize the difference in this problem over the one that you did first? Because let's hope not. The facts here are asking you to calculate the area to the right of the 13. And recognize now that Excel doesn't do calculations to the right. That's kind of the bad news. The good news is that the bell represents 100% of all of the probabilities. So all you need to do is to calculate the part of the bell that you're not interested in, and then subtract your answer from 100%. If you do that, you'll get a percentage answer. If that's what you want, that's fine. You can convert it to a decimal if you want. Or instead of subtracting from 100%, you can subtract from the number 1, and that will give you the right answer also. So the fact of the matter is, if you recognize the difference there and go ahead and do that, you're going to get the big old green check showing that you have the right answer. And I am going to illustrate that for you in a second. A quick side note, if you're hearing that thunder, is that's the result of the hurricane that is hitting the southeast part of the U.S. And I happen to be making my video when that's going on. A major thunderstorm. No, don't sweat it though. So now you're looking at the second question. It looks almost the same as the first one. And again, I don't want you slipping on that old banana peel, is because this is asking you for the probability that a tree is 13 feet tall or more. And remember what I said. The whole bell, when we looked at the bell curve, represents 100%. So in the case of a problem that's asking you for more than, equal to, or greater, at least, those are keywords that tell you that the question you're being asked goes to the right and not to the left. And so I'm going to show you actually two ways to do it that are really only a regular way and a lazy person's way. And when it gets to a lazy person, that defines me. So, but let's show you. You would start out just like we did before, and we would say equal. We would start putting in our normal distribution, just like we did before. And when we got the normal distribution, we would select that. And this time I'm just going to highlight them instead of keying them in. Go to the mean, highlight the mean, go to the standard deviation, do that. Go here and say true. And so I'm going to get the same thing that I got before. Now, that's the area that I'm not interested in. The area from 13 feet on down, going to the left. So what do I need to do? I need to subtract that answer from 100%, which I could do. I'll put in 100% here. And then when I've done that, I could say that this then equals the 100% minus that. The total value of the probabilities of everything under the bell minus the area that I'm not interested in. And Excel is going to give me an 11% there, and I'm going to make it big, just like we did before. And so now you're seeing that as 11%. The same rules apply as before. I can change that to a number if I want. And then I can increase the decimals if I want to 4 decimal places. Or I could change it back to a percentage if I wanted to leave it as a percentage, 10.56%. So that works, and it's not a big deal, and it's fairly easy to do, and it gets you to where you want to go when you're looking for an answer which goes to the right. I mentioned that the lazy person recognizes, that's me, I'm the lazy one. I recognize that I'm going to need to subtract my answer from 100% or from 1. So what I'm going to do, I'm going to do this problem again. And instead of entering it the way I did before, I am going to say it equals 100% minus the normal distribution. I start typing the normal distribution, just like I did before. And then I go ahead and then I highlight the stuff just like I did before. The mean, standard deviation, cumulative is true. I've got it all done. I've got my 100% there. And then I'm going to hit the green check. I didn't put the true in. By the way, you'll notice when I tried to enter that without putting the true in, it stopped me from doing that. So now I'm going to hit it so that everything is complete. And what I've got, look at what I've done. I've got E17, E18, and then I got E20 twice. I've entered the data incorrectly, and the little color scheme is showing me that I've done that wrong. Well, there's a couple of ways to fix that. You notice we've been hitting the green check right along. This time, let's hit the red check. And then it puts me in a position where I can start all over again. So what I'm going to do now is I'm going to say equals 1 minus, just like I started out before. I'm going to make it 100%. Minus, now I'm going to go with normal distribution, just like I did before. Now I'm going to highlight the X. The mean is 11. Then I'm going to go to standard deviation, which is the third thing. And now I'm going to go to cumulative as the fourth thing. Now look at it. I can look at what I've entered and I can see that each of the cells that I want to be shown in the function are displayed in the order that they're supposed to be. Then I hit the green check and I'm going to get the 10.56%. Now I can change that to a decimal, just like I showed you before. I could switch that over from percentage to a number showing me 2 decimal places. I can hit increase decimal twice to get back to the 1056. I also have the option, if I wanted, of using 1 minus normal distribution as opposed to the way that I've done it. The point is, Excel is very user-friendly when it comes to stuff like that. Now we're going to go in another video and we're going to look at some other characteristics of normal distribution. But for now, we're going to move away from this video and get you, again, I don't want to make it too long so you totally lose interest. So hopefully at this point, you feel comfortable in your ability to be able to solve a normal distribution problem. Okay, you've just watched the video on calculating normal distributions. While this video is essential for one of those individuals who's going to be solving statistics problems using Excel on their device, the fact is I know that it's long. There's other things that you're going to need if you're going to be working with statistics either at work or in school or for your own stuff. And just so you know, there is a statistics section of videos that you can find on my website. There's the website address. You'll have to write that down and you can key that into your browser and you can bring up the website and you'll find that all of the various videos that I have are titled, and then all you'll need to do is click on a link on the ones that you're interested in opening. In the meantime, on this video, if you go down below and you have any questions whatsoever about the video, or if you're using a different device and you're having a problem understanding how to do the entry on your device, you can post a question and I promise I'll get back to you very quickly with the information that'll help you to get where you want to go. What's most important to me is for you to subscribe to my channel. That way you'll be able to get copies of new videos as I post them. And at least for now, you really need to have a Google email address. And it doesn't matter if your regular email address is on a different account. You can go through and open a second or third or whatever email address under Google so that you can be a subscriber to my channel. You'll also have to click on that little bell. The nice thing about doing that is as soon as I post a new video, you'll be getting a copy of that right away. And once I get through with the bulk of the Excel stuff, I'm going to be posting videos on how to perform the same function using numbers. And again, if you have questions on what you are trying to do today, you can raise those in the comment section and I'll get back to you as quickly as I can. In addition to that, your comments are going to help me to improve what's being presented. Any comments that you have would be appreciated. If you like what you see and you give me a thumbs up, that's great. But if you don't like what you see, or what you see isn't complete enough to do what you're trying to do, well then give me a thumbs down and tell me why you did that and let me use what you've said to help me to make the videos that you're looking at more useful to you. So hopefully I will see you again on another video. And thanks so much for watching this far on this one.